Alright, so section 13.4 is absolute value inequalities. Okay, so really similar to what we did yesterday on absolute value equations, 13.3, but now this is 13.4. Basically, the only thing that's going to change is instead of an equal sign now, we're going to be dealing with some inequalities, so less than, greater than signs. Okay? Central question, how do you solve an absolute value inequality? First off, I want to do a little review. I want to make sure you remember how to do these. I'm going to work through kind of step by step each one. So, for right now, I have these 4 problems up. What I'd like you to do is go ahead and try and work these on your left-hand side and pause the video to do that. If you have no idea how to do them, start the video and I'm going to show you how to work them out. If you get them all correct, just go ahead and skip through and skip through and skip through, right? Alright, so for the first problem, right, if you already did it on your own, just go ahead and skip through this and make sure you got the same answer at the end. If you do not remember how to do this, let's do it together. So it says the absolute value of x is equal to 14. So if you think about what could we possibly take the absolute value of to get an answer of 14, well, there's 2 things that we could take the absolute value of. We could take the absolute value of 14, that's true, or we could take the absolute value of negative 14. So in this case, there was 2 solutions, and they are x equals 14 and x equals negative 14. Perfect. Okay, that's number 1. For number 2, we've got 2 times the absolute value of x minus 2 equals 8. Now remember, we can't make any assumptions, any conclusions, until this absolute value is isolated or by itself, right? That needs to be isolated or by itself. So that 2 got to move to the other side. The way that we do that is we divide both sides by 2. We get the absolute value of x minus 2 equals 4. Okay. Now we know that this has 2 solutions because it's equal to a positive 4. And we think about what those solutions might be. Okay, well, if we think what would need to be in this absolute value to get an answer of 4, it would either need to be 4 or negative 4 inside the absolute value. So in order to solve for x, we have our first scenario is that x minus 2 is equal to 4. That's our first scenario. And our second scenario is that x minus 2 is equal to negative 4. When we actually solve these out, add 2 to both sides, we get x equals 6. Or, this one down here, x equals, add 2, negative 2. And those would be our 2 solutions for number 2. Good. Okay. Number 3 is going to be pretty similar, just one extra step in there. Remember that we can't make any assumptions about how many solutions it has until that absolute value is isolated. So we need to isolate this absolute value of x plus 3. I think was 6 and negative 2. Yeah, good. Alright, so we need to isolate this absolute value here. The way that we do that is that 4 got to move to the other side, and that 10 got to move to the other side. Okay. So we're going to subtract 10. You get 4 times the absolute value of x plus 3 equals negative 8. Okay, still can't make any assumptions. We still don't know how many solutions. We've got to get rid of that 4 because we're still trying to isolate this absolute value. It's not done yet. Right, divide by 4. We get the absolute value of x plus 3. Yay, it's isolated. Equals negative 2. Okay. Now from here you should be able to automatically, since this is a negative number, and you can't plug anything into the absolute value to get out a negative number, this should have no solution. Right? So no solution. Good. Okay. Alright, the last one, number 4, we got lucky with this one because that absolute value is already isolated. It's by itself. So we saved a little work there. We just got to figure out what we're going to do with it. So first we'll think about how many solutions it has. Since the absolute value is isolated, we can do that. And since it equals 0, there's going to be only one solution. That solution, we're going to think about what could we plug in this absolute value? What could we take the absolute value of to get out of 0? And the only possibility there is to make that a 0. So for our scenario, 2x minus 2, that inside of the absolute value has to equal 0. Okay? Add 2, right? Now we're solving for x. 2x equals 2. So x is going to equal 1. And we're happy with that because that's one solution. So our one solution here would have been 1. Good. So hopefully you got all those correct. If not, you're definitely going to want to do some more practice with those. This is our last section before our test. So I'll have a test next week. All right. So, now to get to the inequalities. So if we have something that looks like absolute value of x plus 2 equals 5, we're going to look at that first, and then we're going to solve it with an inequality. Okay, you can't really see that. Sorry about that. Equals 5. How about that? Good. Alright, so when we were to solve this, we would need to get the absolute value by itself. So we would need to subtract 2 to both sides. We would get that the absolute value of x is equal to 3, which means that we would then have two cases. Either x is 3 or x is negative 3. Notice how those are set up. The x's, positive and negative 3. Okay? Now let's see what would happen when we have the inequality. So with the inequality, let's say it said absolute value of x plus 2 is greater than 5. Okay? We still need to isolate the absolute value in the same exact process we had done before. So we're still subtracting that 2 from both sides. And then we'd have something that said the absolute value of x is greater than 3. Okay? So, close, we're getting there. But we still have to break up into those two cases. Okay, now pay attention to what changes. We're still getting rid of the absolute value, and it's still going to say x and x. That's true. Okay? But now we're going to say greater than 3. That's exactly what it says. X is greater than 3. X is greater than 3. So you're writing the exact same thing without the absolute value sign. Or, right, we have a positive and a negative possibility. So we're definitely going to have a negative possibility here, but this sign is going to flip. Right? So flip the sign. This right here is the hardest part of the lesson. If you can remember to flip the sign on the negative case, you will be probably good throughout this lesson. Okay? It's almost exactly the same. You just have to remember that on the negative case, you flip the sign. Good. Let's do a couple more. And then we'll do some graphing of these. Okay. Perfect. Next one we are going to do is absolute value of x plus 3 plus 1 equals 4. Okay? And then we're also going to compare that to the exact same thing, but over here we're going to do the actual inequalities. Less than 4. Cool. Alright, so to solve this first one, we should already know how to do this. We have to isolate the absolute value first. It is not yet by itself, so we need to get it by itself by subtracting 1 on both sides. You get the absolute value of x plus 3 equals 3. Okay? the absolute values by itself, so we're going to break up into our two scenarios. So first scenario, x plus 3 equals 3. Second scenario, x plus 3 equals negative 3, right? Because you're thinking, what could my insides of the absolute value equal? They could either equal 3 or negative 3. 3 or negative 3. Good, and then when you were to solve those, subtract 3, you would get x equals 0. Okay, over here, subtract 3, x equals negative 6. Alright, and there's your two answers there. Let's see what happens with the inequalities. Still have to isolate the absolute value. That stays the exact same, right? You're going to subtract 1 to get the absolute value by itself, which it now is.